Hello class, this video we are going to review for exam 3. Question number 1. Draw a graph to match the description given. F of x has a positive derivative over infinity to negative 3 and negative 3 to 6, a negative derivative over 6 to infinity, and a derivative equal to 0 at x equals negative 3. Those information tells us the function f increases over negative infinity to negative 3 and negative 3 to 6. Decreasing. The function is decreasing over 6 to infinity. And the function has a horizontal tangent line at x equals negative 3. So let's see which graph match the given conditions. So increasing from negative infinity to negative 3. So increasing. So this one's out. Increasing, this one's out. So we're going to look at B and C. Increasing from negative infinity to negative 3. At negative 3, we should have a horizontal tangent line, so flat. And from negative 3 to 6, increasing, decreasing from 6 to infinity. From 6 to infinity, the function is supposed to be decreasing. And this one is not right. We have to choose B. Let's double check. From negative infinity to negative 3, increasing. At negative 3, flat. And from negative 3 to 6, it's supposed to be 6, increasing. From 6 to infinity, decreasing. Yeah. We choose B for this problem. Next, I just need to double check if the recording, so we're recording right now. Oops. Yeah. So this should indicate is recording. This. Okay. Sure. Your screen is sharing. So you are screen sharing. Okay. So that's the first question. Number 2. Two parts, part A, part B. Part A says to find any critical values, and part B is to find the relative extrema for the given function. Let's see. Let me stop sharing again, okay, just in case. Share full screen. I'm recording. Okay. All right. Function g is x cubed minus 12x plus 11. Its derivative 3x squared minus 12. And we're going to set the derivative as 0. We can solve for x. We have 3x squared equals 12. X squared equals 4. As x equals negative 2 and a positive 2. Or positive 2. So the function does have critical values. This is function g is a polynomial function. Just to remember, polynomial function is continuous from net infinity to positive infinity, and differentiable from net infinity to positive. So it has two critical values at -2 and at a +2. The function has a horizontal tangent line. So we should enter this one, choose this one. The critical values of the functions are use a comma to separate answers as needed. So we're gonna put in -2, comma, +2. Okay. So part B, select the correct choice below if necessary, fitting the answer within your choice. So this is to find the relative extrema. I'd like to use the second derivative test. Second derivative test, need to take the second derivative. The second derivative is 6x. Negative 12 has derivative 0. So 2 times 3 is 6, 6x. And when x equals -2, the second derivative is negative. Okay? And when x equals +2, the second derivative is positive. So double prime is negative, means concave down. Positive means concave up. So the function has a maximum at -2, has a minimum at a +2. So we need to remember that. The relative minimum and the relative maximum, choose this one. A says no minimum, C says no maximum, D says neither. So we choose B, and then we're gonna enter. We do have to know the corresponding value of the two values. So as x equals -2, g of -2 is -2 to the power of 3 minus 12 times -2. Let's see that. All right, so this is -8, and this gives +24, and this gives 27, because 11 minus 8 is 3, 3 added on 24, 27. As x equals +2, we have 8, +8, and minus 24 plus 11. We have, so -16 plus 11 is 95. So we have 11 plus 8, that's 19. -24 plus 19 is -5. So the function has a maximum at -2. The maximum value is 27. The function reached minimum at a +2. The minimum value is -5. So this would be the answer we need to enter here. Relative minimum 295. Relative maximum 92, what is that, 27? 27. Just need to double check the entry. I think if you have a TI-84 calculator and then you enter this function in a calculator, you can easily tell the maximum and the relative extrema. But I don't strongly recommend that because we are trying to apply calculus to solve those problems, right? So minimum 295, maximum 92,27. All right, this is question number 2. Next, question number 3. The graph of a derivative f prime is shown to the right. So this graph is not the graph of f, it's the graph of f prime. Use the information in the graph to determine where f is increasing or decreasing and the x values of any extrema, then sketch a possible graph of f. Let's take a close look at this graph. I want to know what that value is. This is 0, 91, 92, 93. Okay, let me double check. This is 0, 91, 92, 93. All right, so let me take notes. So from 90 infinity to 93, f prime, 90 infinity to 93, f prime is less than 0 because it's below the x-axis, right? The less than 0. From 93 to past infinity, f prime is positive because above the x-axis. So that gives the function f. If the first derivative is negative, that means decreasing, okay? If the first derivative is positive, that means increasing. So that means the function is decreasing from 90 infinity to 93 and increasing from 93 to past infinity. And the function should have a relative minimum at 93. So that's what we get from the graph here. Let's see, how do we choose the correct answer? The function is, okay, so we should choose A. Is decreasing from 90 infinity to 93. And increasing from 93 to past infinity. That's the same way as what we analyzed earlier. 90 infinity to 93, function is decreasing. From 93 to past infinity, function is increasing. So that's the first part. Second part, what is the values of x of the relative minimum? Select the or maximum. Select the correct answer and okay, let's see. The function does have a relative minimum occur at 93. It does have a relative minimum occur at 93 at x equal 93. It does not have a maximum, so choose this one. Sketch a possible graph Okay, so let's see. The curve is going to be like this. Okay, down first and up. Down first and up. At 93. Down first and up. It's B. Okay, so it has a minimum. This one a maximum is out. This one go down the whole time. This one go up the whole time. Only B go down first and go up after at 93 here. That's it. Question number 4. Find the relative extreme points of the function if they exist. Then sketch a graph of the function, right? Let's see. This function is f of x equals 3 plus x to the power of 2/3. The derivative 0 plus 2/3 times x 2/3 minus 1. 2/3 minus 1 is -1/3. So it is 2/3 cube root of x. All right, that's the first derivative of the given function. Is 2/3 times cube root of x. So this first derivative cannot be 0, okay, because the numerator is a constant. But since x appears in the denominator, is 3 times the cube root of x, f of f prime does not exist at 0. That makes 0 a critical value. Okay, that makes 0 a critical value. So the function may have a relative extrema here. So as x is less than 0, as x is negative, f prime, look at it here. When x is negative, cube root of x is negative. So f prime is negative. When x is positive, f prime is positive. So you can see, let's say this is 0. That means when x is negative, it's decreasing, all right, because the derivative is negative. When x is bigger than 0, it's increasing, so it's like that, because f prime is positive. So it has a minimum at 0. Let's see. This one, the relative minimum and relative maximum. This one says no maximum. Okay. The relative minimum points type and order the pair. So we do need to enter a pair here. When x equals 0, when x equals 0, so look at here. When x equals 0, y equals 3. When we need to find a y coordinate for the minimum point, we're plugging in x equals 0 back into the original function f, not f prime. So when x equals 0, y equals 3. This is also the y-intercept of the function, okay? There are no relative maximum. Just double check. It has a relative minimum at 0. When x equals 0, y equals 3. So the minimum value is 3. No maximum. All right, so that's that. Choose the correct graph. So firstly, we know the graph must pass through 0, 3. This is one is out. This one's out. 0, 3 is right here, okay? So minimum, this one. Go down first, go up after. Go down first, go up after. C. Because it has a minimum, right? Minimum at 0, 3. All right, so that's the problem. Question number 4. Next, question number 5. Sketch a graph that possesses the characteristics listed below. F is increasing and concave up from net infinity to 4. That means to the left of 4. Increasing and concave down to the right. I didn't mean to click this one. I just okay. I mean to click this one. So from this is the real number line. This is a 4. To the left of 4 is increasing and concave up. That increasing and concave up. To the right of 4, the function is also increasing, but a concave down, concave down. So it's kind of like this, okay, this. So the entire domain, the function is increasing. So this one definitely is wrong. This one's out. This one's out. This one is increasing. This one is increasing. Concave up first, concave down after. This one is a concave down to the left of 4. And then concave up. So this is incorrect. This one is the correct one. Concave up first, and then concave down from net infinity to past infinity. Concave up, concave down. The entire time is increasing. And that's it. Question number 6. For the following function, give the coordinates of any critical points and classify each point as a relative maximum, relative minimum, or neither. Identify intervals where the function is increasing or decreasing. Give the coordinates of any points of inflection. Identify intervals where the function is concave up or concave down. Sketch the graph. All right. So for this problem, if you have a graphing calculator, that would greatly help you. But again, we're practicing using calculus to solve the problem, right? Use the derivative. This is an application of derivative. So we are not using calculator here. For the exam, of course, you can use your calculator to assist you. Here, I'm going to use a method. It's called the sign chart method. It will help you to, it's not necessary, but it will help you to organize the information here. So we start with the function k. K of x equals 6x power 4 plus 32 x cubed. And then we are going to take the first derivative, x to the power 4, 4x cubed, 4 times 6, 24. 96, 32 times 3 is 96, x squared, all right? Now we're gonna make the first derivative as 0. Let's see what x equal to. We want to actually factor this function. We factor out, let's see, GCF is going to be hold on, 8, 12. Okay, doesn't work. So 24, 12, 96 over 12. So 96 8, 12, and 24 to 12. Yeah, it's the GCF supposed to be 24. $96. Yeah, of course, it's 4. Sorry about that. So factor 24, x squared. We have x plus 4, right? Okay, double check 24x cubed plus 96 x squared. So if we make that be 0, we have x equals 0 and x equals 94. So that's the critical values, okay? Now we're going to do the same thing to the second derivative. 24 times 3, 72, x squared plus 96 times 2, x. And we're going to make that as 0. So we are going to factor first. So we have x here. 72, let's see, 192. 192. So 2 is 24, 3. So it's 24 again. 3x plus 8. And then 2x squared plus 24 times 8. Yeah. Okay, so we're gonna make that as a 0. X equals 0 or x equals negative 8 over 3. Okay, so on the real number line, we're gonna label the points. We have 94 here, and then negative 8 over 3 is about -2 point-ish. So it's gonna be here, -8 over 3, and we have 0. So those are 3 important points. Divide the domain into 4 intervals. And we're going to analyze the behavior of the function over the 4 intervals. From net infinity to 94, first interval at 94. From 94 to negative 8 over 3, negative 8 over 3. From negative 8 over 3 to 0. And from this is 0. And from 0 to infinity. So open. All right. And we're going to pick the testing point, second row. For net infinity to 94, we can pick negative 10. And 94, for that point, of course, the representative can only be in the south. From 94 to negative a over 3, I would choose negative 3. Negative a over 3 is negative 2.7, around 2.7. So negative 3 is in the interval. This is negative a over 3. From negative a over 3 to 0, we'll do negative 2 to negative 1. Negative 1 is better. Negative 1. Again, this is not only method, it's just the method that I recommend because it will keep the information organized. And 0 is a 0, and we can use 1 as the testing point for that interval. And then we're going to have k prime here, which is 24x squared, x plus 4. 24x squared, x plus 4. And double prime, 24x squared, x plus 4. 24x squared. Double prime, 24x, 3x plus 8. X plus 8. All right. So we are going to fill in the table here, the chart. This is k of x. K of x equals k of x equals 6x fourth. So we can copy it here for now. Plus 32 x cubed. All right. So when x equals negative 10, you can see when x equals negative 10, you plug in here. This part is always positive. Okay. When x equals negative 10, this factor is a negative. Positive times negative, negative. For negative, I'm going to put it like this, negative, okay? Negative means the function decreases. And as a second derivative, when x equals negative 10, this factor is a negative. This factor is negative. Negative times negative is positive. So concave up. Concave up. Okay. When x equals negative 4, first derivative is 0. Second derivative is positive because negative times negative, positive. So is flat. The function actually has a flat horizontal tangent line and is also concave up. When x equals negative 3, let's see, this part is positive. When x equals negative 3, it's positive. So it's increasing. Second derivative, when x equals negative 3, negative 3 times negative 3 is negative 9, so also positive. So continue concave up. At negative a over 3, the first derivative is positive. Negative a over 3, yeah. And the second derivative is 0. So the function is increasing. And, it changed the concavity here. Okay. And when x equals negative 1, positive. So continue increasing. and 1, -1, so negative, so concave down. So you can see the function changed the concavity after passing 0. So after passing -a/3, concave down. At 0, first derivative is 0, second derivative is 0, so it's flat here. It's going to change the direction of the increasing, decreasing, and it's the inflection point. When x equals 1, positive. When x equals 1, positive. So it's increasing. And concave up, concave up, concave down, and concave up. So this chart tells us, the shape of the function is decreasing and has a relative minimum, and increasing is concave up. And I'm going to change the concavity down. Should be this. Concave up, concave up, concave down, but continue increasing. It will have a inflation point, so increasing, concave down, concave up, and concave up, concave up, up, increasing and up, increasing and up, increasing down, increasing and up, something like that. Something like that, Yeah, this is 0. This is -a/3. This is -4. Right? Yeah, so if you enter the function to your graphing calculator, you should see something similar. Okay. Let's see if we are able to answer the question based on our chart. What are the coordinates of the relative extrema? Okay. So based on the chart, as you can see, we have one relative extrema. Okay, that is 94. The function has a relative minimum at 94. At 94 relative minimum. Okay. It doesn't have a relative maximum. It does not have a relative maximum. Okay. So after 94, the function is increasing. Okay. The entire time. It stopped a little bit here, but it's increasing. So only have a minimum. 94 minimum. So we should choose this one. And okay, we shouldn't choose. We should choose this one. The relative minimum is, and there are no maximum. Minimum occurs at -4. So when x equals -4, what's the y value of the function? I have to, plugging in here. Let's plug in 6x fourths of 32x cubed. 6, 94. What is it? 6 fourth power, 32 third power, 32. Double check. Sometimes I'd rather use a calculator than using, scratch paper to calculate those things. 6 fourth power, 32 third power. 6 fourth power, 32 third power. At 94. Negative 512. Yeah, I agree that you can make the job a lot easier if you use a graphing calculator. 94 negative 512. Okay, so that's the first part. On what intervals the function decreasing? Okay, see. So the function decreasing in the beginning and then increasing after. So we're gonna write the function is decreasing and increasing here. Function is increasing on I would write decreasing first, right? From net infinity to 94. Decreasing from net infinity to 94. Increasing from 94 to infinity. So here there is an issue. So I would write the interval as 2 intervals, okay? Because at the 0, the function actually kind of flat. So I'll write negative infinity, so 94 to positive infinity, to 0, and comma 0 to positive infinity. Can we just write from 94 all the way to infinity increasing? It's actually not wrong, but just in case we write this to see how the system mark it, okay? So from net infinity to 94, decreasing. From 94 to 0, 0 to infinity, increasing. That is consistent with our charts. It has a flat at 0, okay? That's part B. Part C, what are the coordinates of the inflection point? Okay, we have 2 inflection points. It's very obvious in the chart, up to down and then down to up, right? The 2 inflection point are negative a over 3 and 0. Okay, negative a over 3 and 0. Have order pair. Okay, that's a lot of calculation. Oh no. Again. Negative a over 3. and 0. You have to calculate what's the y value of the function when x equals -a over 3. When x equals 0 is 0, that's easy. When x equals -a over 3, I'm going to use the calculator. 6 negative a over 3 to the power of 4 plus 32 times negative a over 3 to the power of 3. The function is 6x4 is 32x cubed. 6x4 is 32x cubed. I plug in negative a over 3. I hope the calculator can give me a fraction. Oh, it does. Very good. Negative A192 over 27. Negative double check. A192 negative 27. Okay. All right, I think that's it. The two inflection points. I use calculator to find the corresponding y value for each x. Those x's make a double prime equals 0. And D, on what intervals the function concave up, concave down. Okay, so let's see. The function is concave up on up, 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 and up. So the only one that is down is from negative a over 3 to from negative a over 3 to 0. Negative a over 3 to 0 is down. Negative a over 3 to 0. Okay, negative a over 3 to 0. Only negative a over 3 to 0, that's down. All other is up. Okay, so we have net infinity to negative a over 3. And 0 to infinity. Okay, look at the chart. Concave up from negative infinity to negative a over 3. And from 0 to infinity. And from negative a over 3 to 0, that is concave down. Okay. Choose the correct graph. Which one is similar with our graph here? Start with down. Seems this one. Okay. Also, the function is a polynomial function. The polynomial function has degree 4. The shape is going to be like a W. And the leading coefficient is positive. So it's going to be something, the curve is going to be like this. W shape. Yeah. But this one is a little bit different, right? but as you can see, it concave up and down and up, concave up, down and up. So it has to be this one. It has to be this one. Okay, let me double check to see if I click on wrong right answer. I think this test is pretty challenging. Yeah, again, if you have calculator, it will make it a little easier. Increasing 94 to 0. Okay, all right. Next, question number 7. Okay, question number 7. Determine the horizontal asymptote for this function. This is a rational function. What is a rational function? Numerator is a polynomial, denominator is a polynomial. So to find the horizontal asymptote, we look at the degree of the top and the bottom. If the degree of the bottom is higher, bigger than the degree of the top, the horizontal asymptote is y equals 0. The function has one horizontal asymptote, y equals 0. You can always rewind the video to, what is this? All right, so again, it's a rational function, polynomial over polynomial. Numerator has degree 1, denominator has degree 2, denominator degree is higher, so the horizontal asymptote is y equals 0. Okay, that means when x approaches infinity, the function approaches 0. Y approaches 0. That makes y equals 0, the horizontal asymptote. This is a pre-calc problem. This one is a vertical asymptote, rational function. To find the vertical asymptote, you look at the denominator. Of course, sometimes you look at the numerator, but we don't have to in this case because the obviously the numerator and the denominator do not have any common factor. Okay, so if we factor the denominator, we can factor x squared minus 121 as x plus 11 times x minus 11. So the function has two vertical asymptotes. There are x equals negative 11 and x equals positive 11. Okay. So we have two vertical asymptotes. The leftmost asymptote x equals negative 11. The rightmost asymptote x equals positive 11. Right, let's double check. The function has two vertical asymptotes. X equals negative 11, x equals positive 11. So for finding vertical asymptote, you look at the denominator. Yeah, after you simplify the rational function, this rational function do not need to be simplified because the numerator and denominator have no common factor. If it does have a common factor, the function would have a whole, but not this case. The function has two vertical asymptotes. This is also a pre-calc problem. Next. Find the absolute maximum and the minimum. Okay, let's see over this closed interval. Function f is x cubed minus 2x squared minus 15x plus 5. The interval is negative 2 to 0. Take the first derivative. 3x squared minus 4x minus 15 plus 0. And then make this as 0. Make this function first derivative as 0. And let's see if we can factor the trinomial on the left side. You can use whatever the method work for you, okay? I factored as x minus 3 times 3x plus 5. We have x equals 3 or x equals negative 5 over 3. Let me double check we are actually recording. Yeah, it's here, recording. If I mess up the recording, I have to do it again. It's pretty annoying. So that means it's recording now. Okay. Right. So the function has two critical values, 3 and -5 over 3. -5 over 3 is about negative 1.7. So it is in the interval, but 3 is not in the interval. We don't have to consider that. Okay. And then now we're going to consider the following three values, 92, -5 over 3, and 0, to see which one is biggest. Which one is biggest, which one is the smallest. When x equals 92, I think you could use a calculator to get it done. Or actually, we can also use synthetic method. Let's try synthetic method. Synthetic method. So we have 1, 92, 15, and 5. 1, 92, 15, and 5. And we try 92 here. 1, 92, 94, positive 8, -7, positive 15, 19. So the value is 19. You can double check by plugging in x equals 92, -8, -8, -8, again, -16, -11, -11 plus 30 is 19. Yeah, okay. So plugging 0 is easy, right? Plugging 0, we have 5. What if you plug in 95 over 3? Well, you can also use the synthetic method or use a calculator, right? Synthetic method, we put 95 over 3 here. 1, 95 over 3. So that gives you -11 over 3. And we have 55 over 9 minus 15. You know, it's getting very complicated, right? So I would like to use, this is the 55 over 9. And the 15 times 9 is 135. 135 over 9. That is -80. So -80 over 9. And then times that, we got 27, 400. And plus 5. Where's 27 times 5? 35. So that is 535 over 27. 535 over 27. Okay, so I'm going to use the calculator to do it again. x cubed minus 2 squared minus 2 squared minus 2 squared, and then minus 15x and plus 5, right? Plus 5. Five, 3, 5 over 27. 5, 3, 5 over 27. So we got it right. All right, it's very troublesome. Which value is biggest? 535 over 27 is 19.8. So it is the biggest. This one is the biggest. This one's the biggest. The smallest is this one. All right. So we can answer the question now. The absolute maximum is at x equals negative 5 over 3. Five over 3. Negative 5 over 3. The maximum value is 535 over 27. The minimum, absolute minimum, takes place at 0. At 0. The minimum value is 5. Obviously, when we plug in x equals 0, y equals 5. Negative 5 over 3. 535 over 27. Okay, that's it. It's not very difficult, but because of the fractions, it's very troublesome. Question number 10. So we have an open top, square-based rectangular box, have a volume 62.5 cubic inches. What dimensions will minimize the surface area? What's the minimum surface area? Okay, let's see. How do we process this part? We're looking for the length of the side of the base and the height of the box and the minimum surface area of the box. So let's see. The box is gonna look like this. All right. How about we let x be the length of the base because it's square, right? So this is x, this is x. All the four sides is x. How about we let y be the height? Then what's the volume? The volume is going to be x squared times y, right? Base area times height. That is given. The given volume is 62.5. 62.5. And that gives us y equals 62.5 over x squared. And surface area. Let's see how do we find the surface area. Surface area, because the box has no top, doesn't have a top, it has 5 sides. The bottom side is a square, so x squared. The other 4 sides, they are the same area, 4xy. Okay? X times y, this side x times y, so x times y. So 4 sides x times y, so 4 times. So that's surface area. And then we want to plug in y equals 62.5 over x squared. So it is x squared plus 4x times y, which is 62.4 over x squared. Simplify. We have x squared plus this x gonna cancel one of the x in the bottom. So we only have one x on the bottom. Numerator 62.5 times 4. 250. Okay, so that's the surface area in x. X is the side of the bottom square. So we want to minimize SA. So take the derivative, 2x minus 250 over x squared. So I strongly recommend you remember this formula. You don't know how often you're going to use this, so you should memorize it. The derivative of 1 over x is negative 1 over x squared. So that's how I get this derivative very quickly. Okay, 2x minus 250 over x squared. Now we're going to make it equal 0. And then we should have 250 and 2x equals 250 over x squared. And that gives us 2x cubed equals 250. X cubed equals 125. So x equals 5. Because 5 times 5 times 5 is 125. So x equals 5. X equals 5 inches. The length of the box, the height of the box, H height is 62.5 over x is 5, right? Over 25. 62.5 divided by 5 squared, 25. 2.5. 2.5. Okay. 2.5 inches. And the surface area when with this height and the length of the bottom is going to be base times height times base times base surface area. Oh, surface area. So we're gonna have to plug it in. Bottom area is 25 plus 4 times 5 times 2.5. Right, bottom length is 5, so bottom area is 25. The wall is 4 times 5 times the height. The height is 2.5. 75. 75 inches squared, square inches, because it's two-dimensional concept. Actually, I want to double check here, okay? Volume 5 times 5 times 2.5 is the volume. And in the bottom area, 4 walls, 5 times 2.5, 75. Okay. All right. So that's this problem. Next, question number 11. Find the maximum profit and the number of units that must be produced and sold in order to yield the maximum profit. Okay, so we are given the revenue function and the cost function. We had this for the previous exams, right? So we want to maximize the profit, very obviously. Profit function is a revenue function minus cost function. Revenue function is 3x. Cost function is 0.05x squared plus 6x plus 9. So we distribute, we have 3x minus. Combine those two. We have a negative 0.05 x squared gives 2.4, right? 3 minus 0.6 gives 2.4. Minus 9. Take the derivative. We have a negative 0.1 x plus 2.4. Make it be 0. We have 0.1 x equals 2.4. So x equals 24. X equals 24. So the production level should be 24 unit. 24 units. What's the profit? And we're gonna plug in back the function. Yeah, the profit function to find the corresponding profit. Let me double check. Negative profit function 2.4 over 1 24 over 1, 24. So to find the corresponding profit, we would have to plug in here. I'm going to use a calculator. Negative 0.05 times 24 to the power of 2. Start with negative 0.05 times 24 to the power of 2. Plus 2.4 times 24 2.4 plus 2.4 times 24 plus minus 9. Okay. $19.8. Really? Only 19.8 profit? Profit 19.8. So $3 charge. The manufacturer charged $3 for each item, for each unit. Okay. Next, question number 12. Differentiate implicity. Okay, let's see. So we are taking the derivative of each side of the equation with respect to x. All right, that's very important to keep in mind. X squared y minus 2x squared minus 8 equals 0. X squared y minus 2x squared minus 8. Okay, so we're going to take left side and right side with respect to x. This is a product, so I have to apply the product rule. 2x times y, take the derivative of x squared, 2x times y, plus keep x squared and dy dx. And this one minus, take the derivative of x, 4x equals 0, because constant have derivative 0. Let me double check. So we have x squared dy dx equals 4x minus 2xy. And we divide each side by x squared, and dy dx equals 4x minus 2xy over x squared. And that actually is 4x over x squared minus 2xy over x squared. You can simplify, you have 4 over x minus 2y over x. 4 minus 2y over x. So we are looking for the slope of the curve at the given point. So we need to plug in x equals 2, y equals 4. X equals 2, y equals 4. Plug in here. So we have 4 minus 2y, which is 8, over 2. 4 minus 8 is -4, over 2 is -2. Okay, slope is -2. The slope of this curve, oh, is -2. Here actually is asking to enter the derivative. 4 minus 2y over x. 4 minus 2y over x. All right, double check. 4 minus 2y over x. This one is to find the dx dt. The given equation is y equals root x. Knowing we are taking the left side and the right side of the equation with respect to t here, okay, with respect to t. So dy dt, right side we have to take the derivative of root x with respect to x, and then take the derivative of x with respect to t. So it's chain rule actually, 1 over 2 root x times dx dt. I mentioned how important to remember this formula, right? Okay. Let's see, do we have anything to plug in? It says we need to find the dx dt at y equals 2. Well, y equals 2, x equals 4. Okay. When y equals 2, x equals 4. Yeah, when y equals 2, root x equals 2. So this part's 2. 2 times 2 is 4. And we're looking for dx dt. dy dt is given is 1.95. So dx dt is 4 times 1.95. Okay. Four times 1.95. 1.95. 4 times 7.8. 7.8. Next, a circle is growing, its radius increasing by 4 millimeters per second. Find the rate at which the area is changing at the moment when the radius is 11 millimeters. When the radius is 11, the area, the rate of change of the area. Okay, so we know the formula for the area of a circle is A equals pi r squared. Okay, we're going to take the derivative of the left side and right side of the equation with respect to t. dA dt equals constant pi 2r, the derivative of r squared with respect to r is 2r, and then times dr dt. And we are looking for dA dt. Pi is a constant. R says 11. dr dt, the radius increasing by 4 millimeters per second, so dr dt is a 4. dr dt is a 4. That gives 2 times 4 is 8. 8 times 11 is 88. 88 pi. Round to, so keep 3 decimal places. 88 pi. Oh, sorry. 88 pi. Where's the pi? It's here. 88 pi. 276.460. Keep 3 decimal places. 276.460. Since the area is a 2-dimension concept, so we're going to have millimeters per second. Square, right? Square millimeters per second. Right? 15. Find any critical values and any relative extrema. Okay. F is x squared minus 8x plus 21. The derivative is 2x minus 8. Set it as 0, so x equals 4. This is the critical value. For relative extrema, so I use the second derivative test. I'm going to take the second derivative, which give me 2 positive, means concave up. So the function reach minimum at 4. You can see clearly because the given function is a parabola, opens upward. Parabola opens upward, so it has a minimum at 4. The critical value of the function is, use a comma to separate. There's only one critical value, is 4. It's differentiable from net infinity to past infinity, but it has a horizontal tangent line at 4, at the minimum value. And the relative minimum, no maximum, so choose this one. The relative minimum point, we need to use a comma to separate answers, type and word the pair. It's very important to read those information. We're going to have 4. And what is the y value? I have to plug in here, okay? 4 squared is 16. 16 plus 21 is 37. 37 minus 32. 5. 5. Choose this one. Let me double check. X equals 4. 4 squared is 16. 16 minus 16 minus 32 is negative 16. Negative 16 plus 21 is 21 minus 16, which is 5. Okay, so that's the, yeah, again, if you use a calculator to graph the function, you can really make your job a lot easier. But again, that's not the right way to learn calculus. It's the right way to learn technology, but not the right way to learn calculus. And that's it for this one. Next, question number 16. Find any relative extrema. List each extremum along with the x values. Identify intervals, function increasing, decreasing. Okay, so let's see this problem. Only involve first derivative. F of x equals 4 minus 3x cubed. First derivative is negative 9x squared. When we get the first derivative as 0, we have x equals 0. Right? As you can see, the first derivative is negative 9x squared. So when x not equal 0, yeah, either less than 0 or positive, bigger than 0, f prime is always less than 0. So the first derivative is less than 0, that means decreasing, right? So that means the function is going to increase the entire time, but at x equals 0, it flat out a little bit, okay? So increasing the entire time and flat out at 0. Oh, sorry. Misspoke it. Decreasing the entire time, okay? Probably look like this. How do I know that? Because this function is a degree 3 polynomial function with leading coefficient negative. So any polynomial function with degree 3 and the leading coefficient negative, the graph always look like that. So the entire domain is decreasing at 0, it flat out a little bit with the inflection point here. All right, let's see if we can choose the correct answer here. It does not have relative extrema. It does not have a relative extrema. The function is decreasing over the intervals net infinity. I really attempt to write net infinity to past infinity. I'm sure the first time do this one. The function is decreasing over the interval. So entire domain actually is decreasing. It flat out a little bit at 0. Don't know if that matters. Yeah, let's try this one. If not, we know how to answer when we take the exam, right? Notation, use integers or fractions. Use a comma to separate answers as needed. It's gonna be like this, right? Decreasing. Yeah. Next. Question number 17. Assume the function f is differentiable everywhere. Classify the following statement as either true or false. Okay, this is a true or false problem. Why a function can have no extrema but still have at least one point of inflection. Oh, okay, the statement says a function f can have no extrema but still have at least one point of inflection. It is true. The previous problem, remember that, is a good example to demonstrate this is true. It could have no streamer, but has a inflection point in the middle. Yeah, it's simply it's like this one, concave up and then concave down. So that is true. Question number 18. It's also true or false. Yeah. The function f can have exactly one extreme value, but no points of inflection. True. One extreme value, but no inflection. Parabola, think about parabola, right? Has one extreme value, either minimum or maximum, but no inflection. Parabola is a good example. Question number 19. Vertical asymptote, okay? So the vertical asymptote, x equals a number, the number would make the argument be 0. And look at this one, x squared plus 36 is strictly bigger than 0. There's no x would make this argument be 0, so it does not have vertical asymptote. There are no vertical asymptote. Otherwise, there should be a value that make the argument be 0. That's not possible. So there's no vertical asymptotes. Next. This is to find horizontal asymptote. Numerator degree 4, denominator degree 3. Remember that? For a rational function, to find the horizontal asymptote, you look at the degrees of the top and the bottom. When the degree of the top is bigger than the degree of the bottom, that indicates the function has no horizontal asymptote. It actually has a slant. It actually has a slant asymptote. So no horizontal asymptote. Horizontal asymptote. Yeah. Next. Question number 21. This is about productivity M. T is the number of units produced. Oh no, T is the number T of years. Okay, yeah, over time. So T is time here. For a certain product, a productivity function is shown below, but the maximum productivity and the year in which is achieved. So we are going to maximize the function M. Okay, function is a parabola. Parabola facing downwards, right? Of course, it has a maximum value. And you know what? Actually, I want to use a different method for this problem. Because I use the derivative multiple times, right? But if you have a very strong algebra foundation, we actually could process this problem a different way. Negative 2t squared plus 92t plus 880. T is bigger than or equal to 0, less than or equal to 40. So your t has to be within that interval. Otherwise, you have to consider the 40 here. Of course, you can use derivative, right? It's going to be very convenient. I'm saying if you remember quadratic formula, ax squared plus bx plus c, and when the minimum value, so here is maximum value, sorry. When a is less than 0, it has a maximum. How do you find we know it's going to be like this, right? And this point is called a vertex. How do you find h here? H is the x coordinate of the vertex. That actually is the production, is the time that could maximize the m. So we can, h here actually is negative b over 2a. Okay, your b is 92. Your a is 92. Double it is 94. So you're gonna have 23. That's the production level is within inside the interval, so that's fine. It's achieved in year 23. So of course we can use the derivative method, right? With the derivative, we have 94t plus 92. Make it be 0. We have 4t equals 92. T equals 92 over 4. 23. 23. 23. Okay. So the maximum productivity, plugging in again. We would have really just plugging in 92t squared. 92 squared. Plus 92 times t plus 180. 92x squared, 92x squared, 92, 180. Right. 1,238. The maximum productivity is 1,238 units. Year 23. Right, next. Of all numbers that add up to 60, find the pair that has the maximum product, that is maximize the objective function, x times y. Constraint function is x plus y equals 60. So this is a very classical problem. And you can use the method that we used earlier, but just let you know for this type of problem, when x and y are equal, we can maximize the product. So that means x and y are both 30. Then the product would be 900. Okay, we can actually can show you why. So x plus y equals 60, right? So y equals 60 minus x. So the product at the m is x times y, which is x times 60 minus x, which gives 60x minus x squared, right? So m prime would be 60 minus 2x, and make it be 0. This means make it be 0. We have x equals 30. See that when x equals 30, 2 times 30 is 60, 60 minus 60 is 0. So both x and y are 30. So the product, of course, is 900. Derivative implicit, differentiate implicitly to find the dpdx. Let's copy the equation. P fifth power plus p minus 6x equals 55. So we are going to take the left side and the right side of the equation with respect to x. 5p fourths times dp dx. We actually apply the chain rule here. 5p to the power fourths times dp dx and plus dp dx minus 6 equals 0. This part, take the derivative is 0. -6x, take the derivative is -6. dp dx, 5p fourths dx. Okay, so we are going to factor this out. We have 5p fourths plus 1. 5p fourths plus 1 dp dx, and equals 6. And then divide each side by 5p fourths plus 1. 5p fourths plus 1. We have dp dx equals 6 over 5p fourths plus 1. Okay, so that is dp dx is 6 over 5p fourths plus 1. Double check the entry. Since I have to talk while doing the problem, I might make mistakes, but we'll see. Which is a good thing. You would avoid the mistakes I make, right? Right, next, 24. For the following demand function, differentiate implicitly to find dpdx. Same as earlier. This one gonna use a product rule. xp fourth equals 6. We're gonna take the left side and the right side of the equation with respect to x. Left side, we're gonna use the product rule. Take the derivative of x times p fourth plus keep x times the derivative of this part with respect to x. So it's 4p third dp dx. Constant derivative 0. Okay, let me double check. Derivative of x is 1. Keep p to the power fourth plus keep the first part times the derivative of this part. So 4p third times dp dx. Okay, and then we're going to solve for dp dx. And we have 4x p cubed dp dx equals 4x p cubed dp dx equals net p fourths. And we divide by this. We have dp dx equals negative p over 4x. P over 4x. Negative p over 4x. This one is to find the dy dt. The equation that is given is y equals 2x squared plus x. We're going to take the left side and right side of the equation with respect to t. dy dt. This one, I'm going to take the derivative with respect to x first and then multiply by dx dt. So that gives 4x times dx dt. And plus dx dt. Right? And what do we have? We have x equals -3. We're looking for dy dt. X -3, plug in here. X equals -3. dx dt is positive 2. That gives a negative 24. So this is negative 22. That's what I get. Negative 22. 2 times 4 is 8. 3 times 8 is 24. Negative 24 plus 2 is negative 22. Right? I'm a little nervous to submit. Let's see how much I get wrong. Mess up half question here. Question number 6. Oh, this one. Function is increasing. Oh, yeah. So let's go back to chart. I remember this question is about the sign chart method. Increasing is the kx. Is this the function? Part A or B. I got this one wrong, right? Okay, so it doesn't really want you to separate. It does not really want you to separate. Even the function actually flatten all at 0, it does not want you to separate. So now we know -4 to infinity. Okay? Yeah. From the sign chart method, you can see to the right of -4 is positive, right? But it does flatten out at 0. But it doesn't matter. You're going to write from -4 to positive infinity, the whole thing. You don't separate. Technically, my answer, you cannot say is wrong, but now we know that's what the system wants us to enter here, okay? From to the left of 94 is decreasing, to the right of 94 is increasing. Okay, simple. And we mess up that part. Everything else is correct, not too bad. All right, guys, I'll see you on next review.